I want to get this for my Monday. Okay, so it says Elijah ate trail mix 9 different times this week, and each time he ate it, he put an X on his line plot. Okay, and then it wants to know how much total trail mix in cups did Elijah eat. Okay, so over here, when I see all of these X's right here, this tells me that 1, 2, 3, 4, 5 times throughout this week he ate a fourth of a cup. Okay, so I can have, if you want to see it visually, you can have your fourth tiles just over here, and I'm going to put out 5 of them to represent the first thing that they marked for us on the line plot. Okay, give myself a little more space. Okay, and you can see here, I can't even put this together anymore because this is telling me that I just created one hole. 4 fourths, 1, 2, 3, 4. 4 fourths makes one hole. Okay, so here I have one hole and a fourth just from here. Now I'm going to go over here to this part, and it's telling me that on another day he had 2 halves, or at some point during his week he had 2 halves. Okay, so I'm going to have 1 half here and another half. Okay, that makes another hole. And here he has 3 fourths. There's no fraction tile for 3 fourths. It just means that I have to literally put up 3 fourths twice. So that's 1, 2, 3. It's not what I meant to do. Let's take that apart. Okay, so this is the first 3 fourths that he had, and then the other 3 fourths right over here. Okay, so usually we want to figure out how much he had altogether. That's what this is trying to say, that at how much was the total. The keyword here is total. So total tells me that I need to add. So what do I need to do? Can I add fractions that have different denominators? If you remember, we can't. So I have to make sure that all these denominators are the same. I can look at my half and my fourths, because those are the 2 types of fractions I see. I can't make my fourth into a 2 because I can't divide 1 by 2. Because whatever I divide the top by, I have to divide the bottom by. And this is what I mean by that. If I have, where's my tool? Oh, I have to right here. Okay, so if I have a fourth and my other fraction is a half so far. I know I have a bunch more, but this is what the 2 types of fractions we have right now. I can't take this 4 and divide it by 2. Well, I can, but I can't do that to the top. I can't do 1 divided by 2. Okay, but I can make this 2 into a 4. I can multiply. Okay, go away. I can multiply this fraction by 2, and I can multiply the top by 2. Okay, because whatever you do to the top, you do to the bottom, and whatever you do to the bottom, you do to the top. So now I can get 2 fourths equals 1 half. And that's true. If you look at the picture, 2 of these fourths makes that half perfectly. So what I can do over here is I can go ahead, take my pencil away, I can go ahead and put in another 2 fourths, and this replaces one of these halves. Okay, so I'm going to go ahead and take those apart. So I just got rid of one of those halves. Okay, and I'm going to put another fourth in. Okay, and this replaces that half. Now, remember, I have to add. So how many fourths do you see here? And which of those options helps you solve for that? Okay, let's go to Tuesdays do now. So Tuesdays says the same thing. I have another line plot. Okay, let me clear my board here. I have another line plot, and it says, what is the weight in pounds? This line plot shows the weight in pounds of 5 apples. Okay, so this is 1 apple, 2, 3, 4, 5. I can see the 5 apples. They're represented by X's. And it tells me their weight based on where they are on this line. So it says all 5 of these apples will be cut into pieces and placed in equal amounts. Okay, into 3 containers for making applesauce. Okay, so these are 5 whole apples. Okay, think of a whole apple that you're holding in your hand. What we're going to do is we're going to cut up all the apples so that they go into 3 different containers. Okay, so let me draw for you what's going on here. Okay, so let me show you in red just so you know what's going on. This right here is 1 apple. Okay, this is another apple. Sorry, they kind of look like pumpkins. This is another apple. another apple, and another apple. Okay, 5 apples. What we're going to do to each of these apples is we're going to cut them up, okay, so that they can go into 3 equal bins. So here's bin 1, here's, container 2, and container 3. We need all of these containers to be equal to one another, okay? They all have to be equal. So I have to take these 5 apples, even though they all kind of weigh different amounts already when I start with, I have to cut them up in a way so that when I put them in here, they're going to be equal, okay? And then it shows me all the different ways that they could look, okay? And we have to figure out which one of these it could be. So let's first represent them. So I know here that I don't quite know what the measurements of all these are, okay? It looks like from 0 to 1, I've been cut into 1, 2, 3, 4, 5, 6, 7, 8 pieces. So that means my whole has been cut into 8s, okay? That means, let's use this one. That means this first mark here is 1/8, okay? This is 2/8, and so on and so forth. You would fill in each of these. When you get to half, this is 1, 2, 3, and then this could also be 4/8, and 4 out of 8 is half, okay? Zoom out over here for you, if it wants to zoom out. There we go. Okay. Now we're over here, and let's represent those pieces on here with our fraction tiles. So I have 1/8. I have that twice because there's 2 apples that are both equal 1/8. Okay. Then I have another apple that weighs 2/8. So I'm going to have another apple right here that also weighs 2/8. Okay, so one of them weighs 1/8. Here's another one that weighs 1/8. That's 3 apples. And then I have 2 apples that weigh 1/2. Now, same thing as what we were doing for the Monday Do Now. I have all of these right here, and I got to figure out how to make them equal and then separate them into 3 equal pieces, into 3 equal containers, okay? So again, you'd have to go back and think about the common denominator and think about what we already had here. What did I already say 1/2 is equal to? If you're looking where my mouse is, we said that it is equal to 4/8. So you can go ahead and replace one of these half fraction tiles with 4/8. That out of the way, and that replaces. Oh goodness, that's not what I meant to do. That replaces one of the half fraction tiles. Why does it keep doing that? There we go. It replaces one of the half fraction tiles, and now I can go ahead and delete that one, and so on and so forth. You would have them all set up. You would delete this one and make a copy of this one. Okay, and you would just do the same thing, so on and so forth. And this is just to help you visualize it. If you're able to just look at the numbers and say, oh, okay, this is 1/8 plus 2/8 plus 4/8 plus another 1/8 plus another 4/8 because there's 2 of these. And then you're able to go ahead and figure out, okay, which of these images shows all of that. Then there you got it. Okay, so here when I'm done with this and then I get rid of this half because I no longer need it anymore, I used a 4/8 to replace it. Oh no. That's not what I meant to do. Okay, and now I want to delete this one. Okay. You should be able to count all of these 8ths, and that gives you your total. And now you have to basically, what you need to do is see, okay, which of these, when you count all of them up, is also giving you the same answer here. Okay, so you should be able to eliminate. You should know that if this is 1/8 and this is 1/8 and this is 1/8, that means that's 3/8, and we definitely have more than 3/8 here. And you can look here and say, okay, this is 1 whole, 1 whole, 1 whole. Do you really have 1 whole if over here you only have a whole alone with just 2 apples, and then these are way less and nowhere near to be a whole apple? So you can kind of eliminate A and C, and then you just have to kind of look to yourself and say, okay, how many 8s do I have here? Which of these also gives me that amount of 8s? Okay, For Wednesday, we're back to simple. It says Andrew has a toy box. So I want to get rid of this. We don't need that anymore. Andrew has a toy box, and he wants to know the volume of his toy box. Which of these ways, which of these methods will give Andrew the volume of his box? If he fills the inside of the box with unit cubes and counts the number of cubes. If he covers the top of the box, just the top, with unit squares and counts the number of squares. If he covers the face, so each side of the box, and only counts the number of sides, the number of unit cubes, unit squares. My fault. I'm having a tongue twister. If he covers each face of the box with unit squares and just counts the number of squares on the outside of the box for each side, or if you put a tape marked in units along the bottom edge, so the bottom part where two sides meet, and counts the number of units. So which of these methods would give him the volume? And think about what volume is. We're going to come over here on Thursday's Do Now. It says, which number does a digit 8 have a value that is 1,000 times greater than the digit 8 in the number 349,257 and, there's a decimal there, and 83 hundredths. So which of these has a value that is 8? Which of these has the value of the digit 8 that is 1,000 times greater than this one? So here you have to say, what place value is this 8 in? How much is that? And which of these is this times 1,000? Which of these multiple choice options is this number 8 times 1,000? Because it's saying times greater than this 8. So this type of 8, whatever place value this is in, and how much it's worth, times 1,000, which of these would give you your answer for where the 8 is located? So you'd have to find out where's the 8 located in each of these numbers, and which of them is 1,000 times this 8. So go ahead and think about that. Think about place value. We can definitely connect on Thursday at 1 p.m. to talk about that problem. And then over here, this one's kind of similar. For each sentence, select the option from the drop-down menu. So this is a drop-down menu that correctly compares the values. So again, we're back to place value. We're comparing sides. So the value of the 6 in this digit, in this number. So again, the value of the 6 here. So here's my 6. How much is that 6 worth? And this 6 is blank, the value of the 6 over here. So this 6 looks like it's in the ones place. This 6 looks like it's in the tens place. Oh, sorry, that's not what I meant to do. I meant to open it. So this 6 in the tens place, times what? Which of these will give you a 6 in the ones place? And then same thing over here. The 6 in the hundredths, you hear that? Hundredths place, is what with the 3 in this number. So this 3 is in the tens place. This 3 in the tens place times what will give you a 3 in the hundredths place. All right. As always, if you have any questions, comment below on the